finally, let's calibrate the flow rate. The goal here is to make up for any leftover extrusion slop in your 3D printer. So what are some sources of slop? Well, sure, we've already calibrated the E-steps and the filament diameter, but if you had any amount of error in how you measured that, then there's a source of slop. Also just the consistency of the filament you buy, that's a source of slop. And what about your nozzle diameter? Because this is a cheap 3D printer. How many of us are actually buying premium E3D nozzles instead of some cheap knockoff? So is it really 0.4 millimeters or is it something else? And then of course, generic filament quality issues, generic feed system friction issues, generic hot end inconsistencies, etc. Basically, the goal here is to have your expected wall thickness match your printed wall thickness. Every time I've done this calibration, I end up lowering my flow rate, which means less filament being extruded, which means less stringing and blobbing. Of course, if you have a partially clogged nozzle, bad Bowden tubing, or a heat throat that is destroyed by heat creep, then you have no hope doing this calibration. And so, let's start through the spreadsheet. So, of course, I have my checklist here, just making sure everything's taken care of, that your filament's fresh. Already talked about that. Make sure the nozzle isn't partially clogged. Make sure your PID is okay. So if you're on Marlin, you can do a PID auto tune. If you're on Monoprice Mini Delta stock firmware, that doesn't work. And make sure you know what temperature which you plan on printing. And so the instructions, we want to print a simple shape with 0% infill, 0 top layers, 2 bottom layers, or however many you want, really, just not a full solid shape, and a number of walls equal to how many you plan on printing. You may need to enable print thin walls if you plan on only doing one wall. So first off, let's talk about how many walls you want to print. If you have not done any dimensional accuracy calibrations, then that might slightly affect the distance between two lines of filament, so that might cause some slop if you're printing more than one wall. So if you've just completely skipped that, you might want to only print one wall, but I'm going to do two in this video because I believe it's close enough. And your current flow rate, by default, most of the time it starts at 100%. What is your line width? And this is something I want to talk a bit about because I believe the MPMD 101 profiles have it defaulting to 0.35 millimeters for a 0.4 millimeter nozzle. And someone in the Facebook group asked me about that, and I hadn't thought about it much, but opening up the Cura webpage, that just seems to be what they recommend doing, Ultimaker recommends doing for PLA and a 0.4 millimeter nozzle. And also what I found reading this page is that some of the tutorials I found online weren't completely accurate in what the expected wall thickness is, because when you open up Cura and you're looking at your wall thickness, this really doesn't mean as much as so much the line width and the wall line count, because the line width is how wide the printer is going to try to extrude each line as the nozzle passes over, and then your wall line count is how many walls it's going to print for the part. And so really your wall thickness is going to be wall line count times line width, and I confirmed that on the Ultimaker website. So just for sanity, I'm going to set this to 0 and set the wall line count to 2 just so I can keep up with that better. But another question I got is like, well, what is the best line width to use? And it's like, well, I did a slight bit of research, and the best study I could find was the CNC Kitchen did a strength versus extrusion width test, and he found that the strongest prints with his setting were done with a line width of 140% the nozzle diameter. And so of course 0.35 is less than that. It's even less than 90%, which is as low as this goes. So that means a weaker print on the other hand, if you bought the Mini Delta, you probably care more about resolution than you do part strength. So this is just kind of a judgment call for you of how much you care about part strength versus resolution, because obviously the thinner lines you can print, the more horizontal plane resolution you can get. So, I've done this calibration with both, with several different line widths. On my Cartesian 3D printer, I use a 0.4 millimeter nozzle with a 0.4 millimeter line width. The calibration works fine there. I've already done this calibration on the Monoprice Mini Delta with a 0.35 millimeter line width. It works fine, and I've done a few tests at a higher than 100% line width. The calibration works fine. The point is, the slicer is telling the printer to print at a certain line width, and you want to make sure that the real world matches what the slicer is trying to do. So I talked a lot about that, so let's keep going through here. So I'm going to leave the line width to 0.35 and print the object, but I haven't even sliced it yet. So let's open up Cura, and you might have to go into settings and configure setting visibility to enable some of these. I've been doing some experimenting, and so if I go here, I've already messed with the wall thickness. I'm going to choose 2 lines, and for my top layers I'm going to set that to 0. Bottom layers I'm going to set it to the same thing I have my wall line count set to. I want to change my infill density to 0, and also want to click print thin walls, even though that shouldn't affect me here. If you're trying to do this calibration with only one wall, then you definitely need to check that. And so now if I slice this simple 20 millimeter hexagon, which I have uploaded on the Thingiverse page, slicing, you can see if you zoom in, there are clearly 2 lines that it's trying to print there. And if I scroll down, I've enabled a lot of the views for the different flows, which I'll talk about the different flows later and what my experimentation led me to. But anyway, so you're going to print that, and when you do, we're going to measure everything and put them in this yellow spot so that we'll calibrate the average and your new flow rate. So let me make sure I'm measuring the correct hexagon. I've got my calipers, and what you want to do is you want to measure it, but you don't want to stick the calipers all the way down, because you don't want to measure any smushed filament on the first layer that's piling up. You want to measure towards the top. And so you can kind of see about the depth at which I'm measuring it. So this is actually over extruding quite a bit. So 1.02, let's move to the next wall. And so you notice this, my spreadsheet, my equation, which I've written up here, new flow rate is equal to desired thickness divided by actual thickness times the flow rate. It's telling me to drop this pretty darn low, and that should be a bit of a flag that you probably want to redo this calibration, reprint the hexagon with this new value and see what you get. And I say that here in step 8, repeat until you're happy with your results. I'd recommend repeating this process at least one more time with a new flow rate. If you're getting something crazy high, then you may have a partial nozzle clog or incorrect filament diameter set in your slicer. Definitely not getting anything too high. Feel free to add a fudge factor of plus 5% or so if you care more about print quality than dimensional accuracy of the walls. Personally, I would rather slightly over extrude than under extrude. So I'm just going to cheat here and go over to this scratch spreadsheet where I've already done some stuff. I guess I got slightly different measurements the first time I did this, and I'll include this scratch spreadsheet in what I upload, but I went ahead and I did the calculation using the mean, the median, and the minimum and maximum, just to kind of see about my range on all this. So what I decided to do is I decided to just add a bit of a fudge factor, set my flow rate to 70, and print a second hexagon here. And then I measured everything, and as you can see from the values, I'm still not quite getting close to the 0.7 expected wall thickness on this one, so I ended up upping it up to 80%, and then I decided to add a fudge factor of 5% because I'm printing D&D figures and toys. I don't care a whole lot about dimensional accuracy, but the point here is with about 15% less filament being extruded, that's a lot less strinking that you're going to get when you go print your parts. Now, since my camera isn't super great, I'm going to try to open up some photos just to give you an idea of what I ended up seeing. So this is just a general overview of some of my test prints. And did a Benchy MZ 4250 Dragon, a miniature, and then a sort of larger miniature that's, you know, kind of easier to do with this guy. So what I got, so here's, you can see the Dragon, and oh, I'm glad I brought this up, because if you notice, this is kind of support torture here on the wings and everything. And so let's take a look. I've enabled all these different flow rates because what I found was that all existing tutorials, especially since all these different flow options didn't exist in Cura until recently, they all kind of focus on just this flow rate, and really we're measuring the walls. So the only thing we're actually calibrating is the wall flow. So I've added some notes down here in my spreadsheet of basically what I found from my experimentation. Initial layer flow, you always, or at least I always, set that to something above 100% just to help with first layer adhesion. Skirt / brim flow, same thing as initial layer flow. Wall flow, this is what we calibrated, so that's always going to be the calibrated value plus some fudge factor. Infill flow, same as wall flow, because you're not seeing it, so you don't really want to over extrude on that too much. Support flow, which looking at the Dragon reminded me, set to less than the calibrated wall flow, but don't go too low or else the supports may fail. So I did a wall flow of roughly 80 or 85% depending on the print. I think I used 85% with the Dragon. My support flow, I ended up using 60% because when I tried 50%, my supports completely failed on a larger miniature. Then top or bottom flow, you want to keep this higher to avoid holes in your print. And I want to pull up a bad Benchy just to kind of demonstrate. Well, dang, you can't really see it. Okay, there, now you can kind of see the holes in this Benchy. This was done with everything set to about 70% flow rate. So if you put your top or bottom flow too low, then you'll start getting holes in the surface of your print. So your top or bottom flow, you can put that higher than your wall flow and it won't hurt your stringing or blobbing too much, because most of the time that's going to happen on the walls whenever the print head moves and not on the top or bottom layers. And so I make a suggestion to keep that somewhere between 95% to 105%. So there's the Dragon. You can see it on the build plate with all the supports. And there's a Yeti, also sort of a support nightmare. I actually printed this one at a 0.14 millimeter layer height, whereas the Dragon and the skeleton miniature, I did it a 0.7 millimeter layer height, and these were all done with the 0.4 millimeter nozzle. So there's a little stringing test. You know, it's not perfect, but you know, this is way better than what I started with. And I didn't do one of these tests to start with, but you could see it just with my starting Benchy that had stringing, and this is a stringing torture test. And so yeah, I have some little defects on the top here and some tiny hairline strings, but I'm willing to bet if you do a stringing test yourself right now, it's probably not going to look that good. So this is just with the calibrations I've talked about in this video, and no other sort of stringing calibrations. I haven't messed with the retraction at all outside of what's in the MPMD 101 default settings. There's my new Benchy. You know, I took this angle because the main thing I wanted to point out is that this blobbing that was right here even after doing the temperature tower is no longer there. So that's an improvement. I still have some bloopers on this arc, but you know, that's probably due to part cooling, which maybe I'll cover that in another video, trying to improve that. I thought I could do something real quick just to test it, but I ended up using too high of a power fan. But that's a bit off topic. So here's a zoom in of the Yeti. You know, I think that's pretty decent quality for a 0.4 millimeter nozzle and 0.14 millimeter layer height. You know, so the supports came off very nicely. There's another angle. And there's its backside. I was actually surprised the backside looked that good given how the part cooling comes from the front. But yeah, all the supports on the back also came off really nicely. There's the skeleton miniature, and no, this is not the best miniature I've printed with the Monoprice Mini Delta 3D printer, but this is a 0.4 millimeter nozzle. You know, so I'd say that's pretty darn good for a stock nozzle, because for a lot of miniatures you really want to use a smaller nozzle. There's another angle, but the lighting's not great. You know, for example, this Dragon, I found that a lot of MZ4250s models really need a smaller nozzle to look any good, but I decided to try this Dragon anyways, and it turned out okay. I think I broke a wing while trying to remove the support, but I just glued it back on. Did a white Dragon because that was the filament I had. So you know, there's a bit of artifacts on the side, but I don't think you'd see those as much with a smaller nozzle. But you know, for the level of detail I'm dealing with, I was able to remove the support out of the mouth without breaking anything. I was pretty proud of myself there. That's the joy of lowering your support flow. And so, you know, I'd say that's pretty decent quality for a 0.4 millimeter nozzle.
So lastly, we need to put all these new settings into our slicer. So flow rate, I'm just going to leave the base flow at 100 because I mentioned, you know, the gaps in the top of the print earlier. Wall flow, I'm going to set that to my calibrated value of 85, which was 80% plus my fudge factor. Top and bottom flow, I'm going to leave that as 100. Skirt and brim flow, I'm going to up that to 105, as well as my initial layer flow, just to help with first layer adhesion. My support flow, I'm going to drop this all the way down to 60% because just through trial and error that worked. 50% was too low, but 50% didn't fail everywhere, just in some places, so I upped it up to 60% and that worked fine. And I believe there's an infill flow somewhere as well, so let me go check my visibility. Yeah, I have infill flow somewhere, so maybe if I set infill flow to something that's not 0, it'll show up. So yeah, infill flow is going to set that equal to my wall flow. Let's just go ahead and undo these profile changes. Of course, you want to make these changes not on the regular Cura profile, but on one of these MPMD specific profiles. So There you go.
So there you have it. Where to go from here as far as print quality goes, because I know a lot of the focus in the Facebook group is based more on bed leveling calibrations and maybe dimensional accuracy than it is print quality. I would say the next biggest upgrade you can do for print quality is improving your part cooling. I think the easiest short-term solution is just getting some cheap desk fans and sitting them on the back side of the printer, but I'm going to try to explore some other options in a future video. We'll see if I get there.